Hey, Ron, thank you very much. My name is Anton Umnikov. I'm a principal solution architect at Redis, based in Toronto, Canada. And today we're going to talk about large language models, embeddings, vector databases, and everything that would let you build really impressively, really valuable applications based on the large language models such as ChatGPT. Right. The first thing I'm going to talk about is hello world of transformers. Unless you've been living under the rock, you've heard about large language models, ChatGPT. People on this event definitely heard about a lot of them. And most of you, I bet, seen references to this paper that introduced the idea of the transformers, paper called Attention is All You Need, published by the end of 2017. I'm not sure how many of you actually read the paper, right? I've tried to read. I'm not like that in-depth technical guy, but my brief summary of this paper introduced the idea of transformers, actually two types of these transformers, encoder and decoder. And the task that paper was trying to solve by introducing transformers is machine translation. Like they did translation from English to German, then from English to French, and results by themselves were pretty impressive. There is a score called BLUE, which essentially measures the quality of the translation, right? Where 0 being absolute garbage and 100 or 100% is absolutely perfect score, which is not really attainable even for human translators because the variation of the languages and what you can express in one language and cannot in the other language, right? So not only those transformers with attention beat the score on this benchmark quite easily, another important component here was it took just a fraction of time and cost to train them. Like you all probably know that all these foundational models have been trained on the huge amount of data and consumes a lot of GPU. The NVIDIA stock is doing great because of that today. But if you'll just to take away from this paper, like on my level, that would be transformers are great, attention is great, and it costs fraction of traditional methods at the time. Right now, everybody is doing transformers one way or another. Right? If you look a little bit deeper in those transformers, the language translation took two types of transformers to implement. First one is encoder. Encoder's goal is to understand the entire text, entire sentence, or entire paragraph. It pays attention to both left and right of the missing word. So essentially, then they train the encoder transformer, we feed it with the sentence with one word missing. And we train this transformer to predict that word. And that's why for encoder, the attention is both to the right and to the left of the word we're trying to predict, right? Another component of this transformer architecture is decoder transformer. And decoder transformer takes the context from the encoder, the semantic meaning of the phrase we're trying to translate, right? And tries to predict what's the next token would be. So we take in the context from encoder, and we start in one by one predicting the next word. Like if you're familiar with ChatGPT UI, like then you ask a question, it like really doing that word by word. That's not for the dramatic effect. It's really how this transformer separated predicts one word after another, taking into the context, into the consideration all the words that it created, all the tokens that it created previously. Right? Works perfectly fine for the language translation. You need both semantic understanding and the generation. But the amazing things happened right after this paper was published, right? People start tearing this architecture apart and use just one half of it. If you take encoder in isolation, like you would end up with what is called BERT, like bidirectional encoder representation from transformers, which is great in understanding and extracting semantic meaning from the text, from the natural text. Like you've heard already from my AWS folks about embedding. This is how we generate embeddings in a text, but BERT in general is useful for a whole bunch of other applications, right? Even more interesting story happened with decoder side of things. With decoder side of things, remember, it takes the context of the semantic representation of the text we're trying to translate, and that start to predict word by word what would be the next token, the next word in the output. Right now, if we forget about the context from encoder and just feed it the beginning of the text, we essentially have a completion model, right? That given the beginning of the text predicts what follows, right? And that's exactly what GPT is doing, generative pre-trained transformers. Right? OpenAI made it extremely popular, but the architecture of ChatGPT underneath OpenAI is nothing but glorified decoder transformer from the original attention is all you need paper. Right, so you have two types of transformers, both are widely useful. If we look at the evolutional tree of large language models, right, you can see that on the left, you have a whole bunch of encoder-only large language model, and BERT variations are there, right? On the right, and a little bit younger in terms of time scale, you have decoder-only large language model that's based on the decoder part of the transformer, and there you would find your BART, your ChatGPT, your Google Palm, and so on, right? So encoders, right now most frequently used in the vector embedding space, right? It contains just hundreds of millions of parameters, very tiny comparing to the large language models such as ChatGPT. A decoder, your generative AI models, they generate the text. They pay attention only to what happened before and generate the next token. It contains anywhere from a few billions to hundreds of billions of parameters. So a few orders of magnitude more. They are way more heavy and way more expensive to train and so on. That's why we just started to see the rise of this large language model on the decoder only side. Models on the encoder only side being the best thing in sliced bread in natural language processing starting 2018. Right? Now we know that your vector embedding and embedding model is kind of older, less powerful cousin of the generative AI model such as ChatGPT. Now, retrieval augmented LLMs. You probably heard that term as well. I've heard it on the AWS session just minutes ago. The idea behind retrieval augmented LLM is bridge the gap between the retrieval or search only and memory only. Like the ChatGPT, Palm, Google BART models, they have tremendous memory, but they're not aware of anything they have not been trained on. Right. On the other hand, Google, being traditional search engine, they can retrieve any information available out there on the web quite easily, but they lack in this intelligence of large language models. Right. So retrieval augmented LLM, the concept allows you to enhance the results produced by generative AI models like ChatGPT and Palm by adding the relevant content from some sort of database into the prompt of the model, right? It's useful to expose data that is private to your company, private to your enterprise. So in generally, any data that ChatGPT was not trained on, like data before September 2021, but data after, right? There is a strict token limit of anywhere between 4 and 32K, depending on the large language model, in terms of how big your prompt might be. If you're thinking, oh, I'll just feed my entire internal library to ChatGPT and it would answer me any questions, but it doesn't really work that way. You very quickly will hit the limit of the input token, right? You can fine tune, in theory, your model on your own private documents, but it would take a lot of time, a lot of resources, and it's not the easy task to achieve, at least right now. I bet we'll get there in the next few years, but we're not there yet. So if you need to build a retrieval augmented LLM, what you do is take your data, break it into reasonable chunks, generate vector embeddings using variation of that BERT model, right? Then you use vector database to search for the data relevant to the question you're trying to answer, and then you feed these relevant chunks into LLM prompt. Right, so you need vector embeddings, you need vector database, and you need large language model to build retrieval augmented solution. Right, so if you put that all together, that's just the diagram that we created alongside with Microsoft building reference implementation of chat with your private document solution for Azure. In this case, we use in Azure OpenAI embeddings. It's the same as add embeddings of ChatGPT. We use in Redis Enterprise as a vector database, and Azure OpenAI completion engine, which is your ChatGPT, like 3.5 at that time, right? So every time user would ask the question, we would do embedding for this question. We search for relevant pieces of information in vector database and feed it into the OpenAI, so we'll get some response based on the documents that are private to your enterprise, right? Once again, you have large language model, you have vector database, and you have embedding engine, right? You can do the same with other cloud providers, right? You can use Vertex AI, large language model based on Palm, right? You can use embedding, say, from Hugging Face, right? That's a very early iteration of this similar solution for Google that we created. At the time, there was very strict API call limits, right, for embedding, and like basically after you feed like few dozens of embedding calls into Vertex AI embedded engine, I'd say, no, you can't do 429 error. You need to wait. So we switched to embeddings from Hugging Face. Right? But these components, large language model embedding and a vector database, are frankly interchangeable. There's nothing that marries them together that only this combination can work and work successfully. Right? So again, if you oversimplify the picture, like you have large language model, right? It can be ChatGPT, Google Palm, Llama from Facebook, right? For embeddings, you can use BERT, one of the models from BERT. It's very easy to get from ChatGPT, or use ADA model from OpenAI or Gecko from Google, right? I've tried to get onto early preview of the AWS Titan. I wasn't successful as of yet. Maybe Veda and Sherry can help me with that, but I got on the early previews of both Google and Microsoft models and used them all successfully. As for vector databases, again, you don't have to use any specific vector database within your solution, right? You can use traditional database vendors such as Redis, who add vector similarity search functionality to the databases. You can use purpose-built vector databases such as Pinecone, or you can use even Python library like FAIS. Like F here stands, by the way, for Facebook, yet another great contribution of Facebook or Meta to the natural language processing community. So you, frankly, free pick and choose any combination of those in your application, right? There is not even a link between embedding and text and your large language model, right? Data doesn't flow from your embedding generation to, let's say, ChatGPT. There's no dependency between ADA model for embeddings and ChatGPT for completion. So you're free to choose whatever you want. And let's talk a little bit about how you can choose that. We'll skip that part just for the sake of time. I hope people familiar with the idea of vectors, but essentially takes a word or phrase and generates vector embedding from this numeric representation. But important thing, you can do a whole bunch of things with vector embeddings, not necessarily limited to large language model application, right? Semantic search, clustering, anomaly detection, classification, and so on. So if you, allow me, I'll do a really quick demo of using vector similarity search for just pure text search, right? Here we're dealing with database that contains about 10,000 tweets related to the stock market, to the materials market, right? And if we'll do the search with price, with vector similarity search, semantic search, right, we get a bunch of pretty relevant results. So is traditional full text search, right? Again, bunch of relevant results. At this level, they you don't really see the difference. If you'll go to things like oil reserves, right, and start looking for the full text search, oil reserves would return you only one tweet that contains the word oil. It contains the word Federal Reserve, right? Yes, you have linguistic match. Both words are here, but it's not really relevant in terms of what you're trying to find here. Like combination of oil and Federal Reserve, it's not the oil reserve. It's just these two words happen to be in the same tweet. If you'll switch to semantic search with vector similarity search on Redis, you keep getting relevant results, even though both words are not necessarily there as is, right? And if you'll do things like fossil fuels, right, vector similarity search would return you a whole bunch of relevant information. And if you scroll down, there would be a natural gas and coal and so on. But full text search for that body of information would return you absolutely nothing, right? That's just little demonstration of what embeddings alongside with vector similarity search can do without even going into the big, large language models, right? And there are a whole bunch of other things you can do there. Now, how do you choose the embeddings and your vector database, right? I'll stay away from choosing your generative model for today, but how do you choose your embeddings and vector database? For embeddings, there is a benchmark, right, that ranks embeddings models in terms of quality of recall and a whole bunch of parameters. You can go into this Hugging Face page and then GitHub for MTab benchmark to see the details. But interesting fact that text embedding ADA, which is default embedding model from ChatGPT, is just at the 10th place in terms of quality of embeddings generated. Right, there are a whole bunch of models above it, right? Another thing that stands out here is the sequence length, is how big is the chunk of the text that you can encode. It says 8K here, 8K token. It sounds really nice in theory, but in practice, the GPT 3.5 model token limit is 4K, right? Even if you'll manage to generate embedding of 8K length, what you're going to do with it? Then you do your retrieval based on that, right? You have to be reasonable about how big the chunk size is, right? There are a whole bunch of other considerations, but once again, you're not married to the embeddings provided by the same vendor as your large language model. And there are a whole bunch of other factors to consider. One of them would be cost, right? In terms of cost, again, if you look at the pricing for OpenAI, the ADA embeddings, right? There are a whole bunch of zeros and then one, and a generative AI, so actually making the predictions, like using the ChatGPT as ChatGPT, looks like it's 20 times less expensive. And yes, that's true. But the reality is, and that's from my personal experience working on one of those projects, right? Embeddings would be a really big part of your bill. And that was the case for me. Then I was working on Chat with Your Own Documents project using OpenAI and OpenAI embeddings, right? Basically, find a needle in a haystack, you'll need to index entire haystack multiple times, even though you're doing one request to find this needle in the haystack. So you'll be re-indexing and re-embedding your entire corpus of documents multiple times, especially in the development phase. You'll be playing with your text splitters and how big is the chunks of text you want to do. So really pay attention to how much the embedding would cost you. right? And especially in the development stage, that might be the biggest chunk of your build. But nothing stops you from using the embeddings, say, from Hugging Face. Hugging Face became the default standard for all the open source large language model, natural language processing things. Some people call it the GitHub of machine learning. And if you're using high-level frameworks such as LangChain, changing your embeddings from paid OpenAI embeddings to free, run within your notebook embeddings from Hugging Face, it's literally changing those 2 lines of code. Right? And unlike the large language model that is really hard and challenging to run on your own hardware or in your own notebook, embeddings model are tiny and can totally run locally on your own hardware. Right. So as a starting point, right now, my default to go would be one of the Hugging Face embedding. And then I'm sure that, hey, I got everything I need. I got stable embedding, stable toolchain. I might or might not switch to the embedding from the provider, depending on what customer would ask. Right. Now, for the vector database, right? Vector database essentially looks at this row of numbers that.
Hey, Anton.
Yep.
Anton, what we want to do is just we've got some additional content. I want to make sure we try and sum it up in the next 5 minutes or so, if at all possible.
Absolutely.
Okay.
We're almost done, actually. Okay. Right. So again, what vector databases does on a high level is doing one of the similarity algorithm. Cosine is probably the most popular between multiple vectors. So given this vector, show me the vectors that are most similar to this one. Right? The math behind the cosine similarity is very straightforward. My kids who are in high school right now can probably figure it out on their own. Right? The Python code for, again, doing cosine similarity between 2 vectors, again, is very straightforward. If you're doing that at scale and you have really large number of vectors to compare, you need to introduce some concept of indexing, right? And again, there are well-known algorithms published and so on, KNN, K nearest neighbor, or ANN, approximate nearest neighbor, right? And it's hard to do wrong. If you cannot implement these algorithms, you probably should not be in software business at all. So the real differentiator, unlike for embeddings, where quality of embeddings and training data and so on is really important, right? For vector databases, the differentiators are on the database side of things. Things like scalability, ability to work with transactions, performance, high availability, as you go to production deploying things like security and compliance and so on, right? So embeddings, it's hard to train, not as hard as generative model, but still there are a whole bunch of factors to consider, including what language they operate with and so on. For databases, the vector part is simple. The database part is complex, right? So choosing between all the database options that are out there, regardless of the fact that I work for Redis, I would choose the existing database vendor that figured out the database part and just added vector similarity on top of that, rather than ground up vector database, right? Because they have a lot of things to catch up of building the production quality database first, right? So speaking of Redis, right? Redis added vector functionality to Redis Stack and Redis Enterprise a couple of years ago, way before the ChatGPT was a thing. Right? You can run it for free on your laptop or even inside Google Colab Notebook, as well as on all major clouds on-prem as either self-managed or managed offerings. Right? A whole bunch of compliance and security certifications trusted by largest enterprises on the planet for running the most critical workloads to their business. So if you're choosing a vector database, give us a call. We do have things to offer for your development playground, which are absolutely free. It's called Redis Stack, and Redis Enterprise can really elevate that to the production level. Right? That's not being a vector database and doing augmented retrieval. It's not the only thing that vector database can do. I would skip like most of the talk here, but there are things like memory and cache. Cache is like traditional things for Redis, and we can do that really well and keep doing that really well. Right. Funny thing is, ChatGPT themselves, OpenAI, does use Redis. Right. There was a big outage in March 2023 where the culprit was one of the client libraries working with Redis. Right. They reached out to us. We quickly helped them to fix that client library, like, and go forward. But testament we get from OpenAI folks from ChatGPT is speaking for itself, right? They're saying the Redis is the vital part of their ecosystem, of their solution. Right, so if I may to make a summary, right? Vector embedding is not just some weird thing that happened to be used in combination with generative large language model. It's an older, smaller cousin of generative large language model. If you build and retrieval augmented LLM, chat with your own enterprise documents, you need embeddings, vectors, and large language model. And you can freely combine all of them, right? They're not married to each other. Like if you're looking for embeddings, look for model capabilities such as language support and cost. It's totally okay to bring your own. And if you're looking for a vector database, look really closely at the database part, not the vector part. Vector part is easy. Everybody can do that. It's relatively straightforward. Look at the things like scalability, ability to handle transactions, security, compliance, and so on and so forth. On that note, I'll just leave this slide here. You can get to the whole bunch of notebooks and tutorials. You can get free version of free instance of Redis Cloud, Redis Stack, and so on and so forth.